Space is defined by constant, sweeping motion. Massive planetary bodies locked in permanent orbits against an immense void. Close to home, we have the Moon, Earth's natural satellite, bound to us by gravity as it endlessly circles our planet. Millions of miles away sits the Sun, the singular engine radiating the light and heat that define our solar system. Most of the time, these three bodies operate entirely independently across the empty expanse. But on rare occasions, their separate orbital paths sync up perfectly, bringing them into a precise straight-line formation. When that exact alignment happens, it projects a massive cone of geometry across space, dragging a creeping shadow over the Earth and turning daylight into darkness. The mechanics begin during a specific new moon phase, when the Moon slips exactly between Earth and the Sun. Moving into position, the Moon physically blocks the incoming solar light rays, forcing a massive shadow to stretch across space and strike Earth's surface. This shadow is divided into distinct zones. The outer, lighter region is called the penumbra. If you are standing within the path of this lighter shadow, you will experience a partial solar eclipse. The Sun is only incompletely blocked, appearing as a sharp, brilliant crescent. But the visual changes drastically if you fall under the innermost, darkest, and most highly concentrated center of the shadow, the umbra. Observers positioned directly inside the umbra witness a total solar eclipse. Here, the Sun's main body is completely obscured by the Moon. Viewing this alignment requires strict safety measures. Looking directly at the event without specialized protective goggles exposes the human eye to intense, unfiltered light that can cause permanent blindness. Safely viewed, a solar eclipse reveals a stunning quirk of spatial scale, allowing a relatively tiny rock to momentarily overpower the brightest star in our sky purely through perfect positioning. The entire process flips on certain full moon nights. In these instances, the Earth places itself directly between the Sun and the Moon. Because of its larger size, Earth casts a massive shadow that easily engulfs the entire lunar surface. But when the Moon slides into the darkest part of Earth's shadow, it doesn't vanish into darkness. Instead, it turns a striking, brilliant red. This happens because of our atmosphere. When sunlight strikes Earth, the atmosphere acts as a filter, scattering shorter blue and green wavelengths into space. The longer red wavelengths pass through. This remaining crimson light bends inward, funneling into the shadow. Bathed in this intense glow, the Moon takes on an appearance historically known as a blood moon. This red hue is actually the visual projection of every single sunrise and sunset currently happening on Earth, shining simultaneously onto the lunar surface. This raises an obvious question. If the Moon completes a full orbit around our planet every month, why don't eclipses happen every time it passes by? The answer lies in the angles. The Moon's path is physically tilted compared to Earth's orbital plane. Because of this bend, they rarely align perfectly. Month after month, the Moon's shadow sweeps too high or too low, passing harmlessly over the poles. An eclipse requires these celestial bodies to cross paths exactly at the intersection of their tilted orbits, making it a highly fragile mathematical rarity rather than a monthly guarantee. Before we understood this exact mathematics, humans looked up at the darkening sky with terror, inventing stories like a giant cosmic snake devouring the Sun. Driven by these fears, ancient populations would lock themselves indoors and refuse to eat, terrified of the sudden, inexplicable darkness. Over time, observation replaced panic. People devised creative, safe, if sometimes unusual, methods to view the event without damaging their eyes. Today, we look up equipped with precision instruments, actively tracking and studying the sky to map the exact moment the shadow will arrive. We can confidently discard ancient superstitions, relying entirely on the verified facts of the universe. Eclipses are predictable, majestic displays of celestial physics. They remind us that